I didn't have an idea for the name for this lecture, so this is the nameless lecture. I'll give it a name later. So one of the questions that came up in the forums made me realise that there was an idea that I really should have covered in more detail. And this is the idea about how we use variables to record the state of a behaviour. So, I mean, when I introduced global variables in a script, I talked about how you can use them to change the behaviour as parameters to the behaviour. So you can change the behaviour by, for example, you know, you'd have a vector in there which would be the direction of movement, and you could change that vector in order to select which way the object was going to move. But global variables are useful for more than that. You can actually use them internally in your behaviour to keep track of the state of that behaviour. And so the state could be a variety of different things, but it's like, what is the behaviour doing at the moment in some fashion, and how does that state evolve over time? We can use that then to make behaviours that change what they do, so that they're not always just doing the same behaviour. The simplest example, somebody asked, how would I make an object that moves up and down? So we know how to make an object move up, it's just translate up, and how to make an object move down, say translate down. But how to make it move up, stop, turn around, move down again, well, we won't be turning around, but moving up and down. The way to do this is to keep a variable moving up, which is our state, which is telling us whether we're moving up or down at the moment. And initially it's going to be true, so we're going to start out moving up. And every time we update, we're going to check this state to work out what we're going to do. So if moving up is true, we'll move up. And if it's not true, we'll move down. Okay, so that means that we can have our behaviour do two different things depending on whether the state is up or down. Now on its own, that doesn't do what we want because moving up never changes. So moving up is always true, and so it'll always go up. But if we set two limits top and bottom, then we can check in each frame, we can check whether we've reached the top. If we've reached the top, if the y position is greater than or equal to top, then we'll flip the value of moving up to false, and so we'll start moving down. If we've reached the bottom, then we'll flip it back to up, to true, so we'll move up. So now as we, I haven't got an example of this script, but as we run this script, we'd start up moving up, and we'd move incrementally up the screen until we reach this top position, and then when we reach the top, this if statement would be true, and so we'd switch moving up to false. And then on the next time we run around, moving up would be false, and so we'd be running vector 3 down, and we'll keep running this one on every frame until we reach the bottom, and this if statement fires, and then we switch it to up again, to true, to go up. And so in this way we can make an object that changes its state over time and acts differently depending on how its state is changing. Now this is a really simple example, just using a single Boolean to switch between two different states, but we can actually have as complicated a state as we want. An example of a slightly more complicated state would be to have a behaviour here that only does something every 3 seconds. So we might use this for reloading our gun in asteroids, for example. So we have a parameter here which is how long it takes to reload, and we have a state which tells us how long are we currently reloading, and if so, how long do we have to finish reloading. So when the state is 0, that means that we can act because there's no more time left before we reload. But if the state's greater than 0, that means we have to wait. We have to wait until it gets back down to 0 before we can act again. So every frame, we subtract the amount of time that's passed from reloading. So reloading goes down on every frame. But if the reloading is less than or equal to 0, then we're allowed to act. And we do whatever it is that we're meant to do, and then we set reloading back to 3. And so reloading starts at 0, which lets us do something immediately, then goes up to 3, and then gradually over time goes back down to 0, then goes up to 3 again, then gradually goes back down to 0, and then up to 3. And every time it reaches 0, we do something. Now whatever that thing that we're doing is up to you, but this is a behaviour then that will act we'll do something once every 3 seconds and then wait to do it again. So the state here is actually now a time, it's a number, and it's the amount of time that we will wait, we have to wait before we can act again. So we can use these variables to record the internal state of our behaviours, and we can keep quite complicated internal state if we want to. We probably won't be doing anything with really complex state in any of the examples we're doing, but simple examples like this are really handy. And this is a sort of behaviour that you could use quite often in Unity to keep a timer, a very simple timer. So going back to our game, the first thing that we noticed was that bullets don't inherit the ship's velocity. So having made our prototype, we were saying before in the prototyping process, you make a prototype and you test it, in this case testing it by actually playing it, and you notice that you've got a problem there in that while we're stopped, the bullets fire nicely, but when we're moving, the bullets actually sort of pile up in front of the ship because they're not inheriting the ship's velocity. So we're going to fix that. I'm going to stop playing because as fun it is. So to fix that, what we're going to do is, so our bullet move script has a velocity parameter, or a velocity variable. So this is how fast the object is moving. Now we don't actually. So when we create a bullet, we have to give it a velocity. So so what we're going to do is create our bullets with a different velocity depending on how fast the ship is going. So that's fine, but what we need to do is when we create the bullet, so we go down to the fire bullet script, which is on the ship. So here we said, when the user presses the key space, we instantiate a new bullet. And we're instantiating it at the gun position and with the gun rotation, but we're not initially setting that velocity, which is curious actually, because the velocity must be initially set somewhere. Anyway, so what we need to do is set the bullet's velocity. Now, the first thing we can do is have, we probably want to create a muzzle velocity for our gun, which is going to be a vector 3, which is going to be how fast the bullet normally moves. So we can, so that's going to be our parameter for how fast do we fire bullets. And we can say, now this is a tricky thing. What we want to do is set the velocity of that bullet to muzzle velocity. But in order to get it, that velocity variable is not on this script. It's on a different script. It's on the fire bullet script. So somehow or other, we've got to get at the fire bullet script for this bullet and set that velocity value. So what we can do is we have Unity has a method called. Let me just get this right. Every game object has a method called GetComponent. And the GetComponent method, or function, takes the name of a component that we want to get. So we're looking for the fire bullet script on there. So now we can assign that to a variable. So I remember I said before that every script you creates a new class. So that class, so you can have variables of that class. So now fire bullet is a variable of type, well, little f fire bullet is a variable of big F type big F fire bullet, right? So this is an instance of that script, and in particular it's the instance of that script that comes attached to the bullet, to each bullet object. Now this is safe to do because we know that the bullet prefab always has this fire bullet component attached to it. If we didn't know that that component was necessarily there, then trying to get a component that we don't know is there will sometimes result in problems. Unity will actually return something here, but it will just return what's called a null answer, which just means there is no object. It's the empty object. But we know that the prefab, if we go back and look at our prefab, we know that our bullet prefab, which we're using that one, always has, oops, I've got the wrong name. Sorry, I got the wrong name. That's not fire bullet, that's bullet move. There we go. That's what you get when you don't look at the docs. So we don't know it has a fire bullet because it doesn't have a fire bullet. We're going to call it bullet move. There we go. So correction, we know that every prefab has a bullet move script attached to it. So we can get access to that bullet move script like this. Now that we've got that script, we know that that script has a velocity variable on it. So we can now set that velocity variable. Dot velocity equals muzzle velocity. And if we look at the bullet move script, it will use that velocity on every in order to decide how fast the object's moving. So now, every bullet we create, we can set muzzle velocity here. Now, you might ask, why didn't we just add a muzzle velocity field directly to the bullet move thing? Well, by setting it here, well, partly it means that we can parameterize that in this space, but also it means that we can, rather than just setting this to the muzzle velocity, we can now calculate this velocity based not only on this variable, but also on the speed of the ship. So well, let's try that first, just to make sure that I've got the right thing. So there, it's not moving, and the reason why it's not moving is because if I come over to my fire bullet script here, my muzzle velocity is 0. So I want to change that. I think that's the right direction. Let's try that. There we go. That's a bit slow. Let's try increasing that to 10. There we go. So there's bullets firing it. That's kind of nice. Okay, but again, when we speed up the ship, now our ship can actually move faster than our bullets, which is a bit of a problem. So what we want to do is actually add an extra thing on here. Right? We want to add the ship velocity. Now we don't know what that is yet, so we've got to have a variable ship velocity. Okay, so what we're going to do is calculate a value for this variable, and we'll write the code for that, then add that velocity onto the muzzle velocity in order to get the velocity of the bullet. So the bullet will inherit the ship's velocity, but then add the muzzle velocity onto that. Now, in order to do that, we need to know what the ship's velocity is. We could do a lot of messing around to try to work that out, but the easiest way is to just keep track of the position of the ship over time. So if we think about the velocity of the ship is basically how far it moved in the last time step divided by how long that time step was, right? So if it's moving at 1 meter per second, then if the last frame was 1/30th of a second, then it should have moved 1/30th of a meter. Anyway, that works around. So if we, so what we want to do is say, so the ship velocity is the current position, which is transform position, minus the old position, which we're going to have to work out somehow because we don't know what it is right in the moment, divided by how much time has just taken. Okay, so that gives us the answer to what the ship velocity is, but now there's a problem in that we don't know what the old position was, so now we have to go back and calculate that value. Now the easiest way to do that is to actually just record it. Every time we go through a frame, we'll record the old position. So old position equals transform dot position. Okay, And we'll need to have a variable for that. So we'll call that a variable in here, old position, which is a vector 3. Okay, so now on every time I do an update, I'll calculate take the current position, subtract the old position, use that to get the time, and then I'll save the current position as the old position, so the next time I come around, it'll be remembered. So what I'm doing is that I'm remembering transform.position from the previous frame. So every frame, the last thing I do is remember the old value, so that when I come around to the next frame, I'll have a record of what the old value was. And so from frame to frame, I will always remember I'll have the current value, and then I'll have the old value stored in the previous frame. So it's got to be the last thing I do. If I put this up here as the first thing I did, then when I came to here, old position would be the same as transform.position, and so it would be 0. So the last thing I do is remember what my position was on the previous frame. Okay, so now there's one more thing left to do, and that's on the first frame, on the first frame we don't have a value for old pos, because the first frame we just start here, we come down through our code, we get to here, old pos hasn't been set. So we need to record the initial position of the ship as the value of the first frame. So what we need to do is function start so at the beginning when we first create the script, we'll just store old pos equals transform dot position. So this is a very common pattern in programming in Unity. If you want to remember the value of something from the previous frame, you have a variable which is a state variable which records that value. And then you initialize it in the start routine, and then on every update you store the old position, store the new value into the old value, so that on the next frame it'll be remembered. But before you do that, you use the old position. So we do some sort of delta between the current position and the old position in order to get us the time. So this should work. There's no errors, that's nice. So let's see what happens. So if we fire bullets, okay, that still works. Now we move forwards. That looks like it's working. Oh, yeah, that is working. They're definitely inheriting the ship's speed. And if we turn around and fire, okay, that's not right. The bullets are coming out sideways. That's a bit weird. Okay, so what is happening there is I made an interesting mistake here. So now we've got to worry a little bit about coordinates. The velocity vector is in the bullet's local coordinate space, but the bullet's local coordinate space is rotated by where the gun is, and so if you think about it, I can draw on the board. Actually, I'll draw on the board over here. If I have some chalk, is there any chalk? Yes. So this is a bit weird. So there's our space. Our ship is there. Our bullets are created. Now the bullet's local space looks like that, right? So if our ship is pointing that way, our bullet's local coordinate space is that way, and the bullets are going to be moving. I think they move. Which way did they move? Let's have a look. So we said the bullet was moving in the y direction, right? So this is the bullet's y direction, and so the bullet's moving up that way. So when we do translate, we're moving the bullet along that way. But the problem is that the ship, when we calculate the ship's velocity, it's in this coordinate space, right? Because the ship's transform is in the world space. So now when we say the ship is moving, if we said the ship is moving that way, then we're saying that's actually, what did I say? That's x. So then if the ship was moving that way, we're adding this velocity is 1, 0 or something, which is, so it has an x, it's moving in the x direction. So it has, so, but the problem is we don't want to add, if we fire a bullet, the bullet's x direction is that way. So we don't want to add the ship's velocity in the world's coordinates. We want to add the ship's velocity in the bullet's coordinates. Does that make sense? So if we added, so in the world's coordinates, the ship is moving along the x-axis in that case. But in the bullet's coordinates, which is that, the ship is moving along the bullet's y-coordinate. So what we need to do is translate this, the ship's velocity from world's coordinates into bullet's coordinates. Now the good thing is that Unity provides us a method to do that immediately. So we don't have to worry about the maths behind that. All we have to do is say bullet.transform .inverse transform direction. So I'm surprised I can remember that one. Ship velocity. So there are two methods on every transform. They're transform direction and inverse transform direction. Transform direction takes a vector in the local coordinates and converts it to a vector in world coordinates. Inverse takes a vector in world coordinates and converts it into a vector in local coordinates. So we can just say ship velocity equals bullet.transform. So now that, so let's put a comment in there to make it clear. Transform from world coordinates into bullet coordinates. Okay, so now the muzzle velocity is in the bullet's coordinates, the ship's velocity is in the bullet's coordinates, so now it makes sense to add those two together in order to get a thing. So now if we try that script, let's do that and try that out. So that still works, that's good. But now if we fire that way, yes, and so if we speed up, it'll do that. Actually, there's something wrong there. What's going on there? There's something strange going on there. Oh no, that looks right. If I fire several bullets, they seem to be, some of the bullets seem to be speeding up more than others. That's a bit weird. Not quite sure what's going on there. What have I done wrong? I don't know what I've done there. Something seems to be making the bullets move, some bullets move faster than others. Anyway, that's not really important right now, so we'll sort that out later. Anyway, what I wanted to, so that messing around with coordinate spaces is a bit tricky, but what I really wanted you to get out of that was that, so every script we're creating establishes a new class, and the bullet move, in this case, the bullet move script creates a bullet move class, and that class has its own methods and its own variables. And we can then, when we have an object with that class on it, that script on it, we can get that component and treat it as a variable in our scripts. And we can refer to those public variables and public methods in the script in the same way as we would in any other class. So, for example, we did it last lecture. We used the space object, which declared, we had a space script which declared a frame and had a function for a random point in that frame. And then we could use that space as a type and declare a variable of type space. And then using that variable, we could access that random point method, or we could access that frame if we wanted to. So we can create classes. We don't need to create multiple classes. I mean, we could put everything on a single script if we want, but separating loosely related code into different scripts makes them easier to follow. So again, it's a style issue. It's a readability issue. So the idea is then to work out, well, are these two pieces of code so tightly related that they all belong on the one script, or are they loosely enough related that they could put in separate scripts? Now, completely distinct behaviors should generally be in separate scripts. But sometimes you have loosely connected behaviors which need to refer to one another. That's fine. But if things are too tightly connected, they should probably belong in the same space. Having too many scripts makes your code difficult to read again because it's hard to find the script where whatever behavior is happening. So it really ends up being a judgment call on your part. If you send everything across 100 different scripts, then it might be hard to find where in the script something is going wrong. On the other hand, if you put everything into one script, it might also be hard to find where things are going wrong because you don't have the easy ability to look up things. So write your scripts in a way that they sort of make logical sense as units, and then when you know that the problem is with the firing bullets, then I know to look in the fire bullet script. So I mean, it's a real style thing, and it's a bit of something that you get used to over time. So yeah, just try it and see. The other thing is, so I said that you can access game. So I said that you could access these when you create new classes. You can use them as types like this to declare a variable. You can also access them on the fly using the GetComponent method. GetComponent is on the game object, so any game object you can get any of its components, and it'll take a name, which is a string, and return the component. You've got to make sure that the capitalization and spelling of the string is important, right? So if it's capital T transform, you've got to put capital T transform in GetComponent. And you've got to make sure that you know that the component is there before accessing it. Obviously, not every object has every component. And in particular, if it's your own scripts, then make sure that the object that you're trying to get the component from has that script attached to it. So an example, if we instantiate the bullet prefab, we can then get the bullet move component from that prefab because we know that all our bullets have a bullet move prefab. Most of the standard components that Unity provides, such as the transforms, the game objects, and we'll look later at rigid bodies and colliders, they have existing variables on them. So you don't need to say GetComponent transform, you can just refer to transform, which is what we've been doing so far. Any game object can actually also have a game object variable which usually points back to itself. You also have a transform has a game object variable, so it sort of points back again. We'll also look at using the rigid body and collider variables, but this means that you don't have to for the commonly used ones, you don't have to keep saying GetComponent transform. You can there's just a variable for it. Okay, so how are we going on time? Let's. I didn't bring my phone. So okay, we're half time. Good, that's good. So the next problem that we're facing in our game is that sometimes, if this was a real game, because we're creating our asteroids randomly, sometimes we create asteroids, and it's not going to happen now, there's a possibility that we'll create asteroids really close to the player, and even on top of the player, which would be a bad thing if this was a game, right? You normally have some sort of area of safety around the player that we don't create our asteroids in. So we're now going to go back to our asteroid creating script and try to make a safe zone around the player so that the asteroids don't appear too close to the player. So let's stop that. The way we do this, here's our asteroid creating script. So what we did was we said we created a number of asteroids. Each asteroid we instantiated from its prefab, and then we set its position to a random point in space, and we set its parent to the transform so that we set its parent to the joint object transform. So remember, they're all children of asteroids because we're setting the parent that way. Okay, so now there's a problem in this code, which is that the position that's returned by space.randomPoint could be really close to the player, or could even be on top of the player. So what we want to do is say, okay, if the random point we choose is too close to the player, choose another point. Now, we already know how to do that. We can say something like, so let's say a threshold for how close we can be. Minimum distance, let's call it that. Let's say it's equal to, pick a number, 1. And we'll tune that later. Okay, so now we say if asteroid, actually let's get this, let's not do that, let's do this. Let's put that value in a variable. Okay. There we go, p equals. So that doesn't change, so that on its own doesn't change our code at all, or it doesn't change what our code does, but we're just putting our random variable in, a random point into a variable first, and then I've just written this round the wrong way, so let me correct that. That equals that. So we're going to put the point into a variable, and then we're going to put that variable into the transform position. The reason why we do that is that we don't have to keep using the name asteroid transform.position in our code, because that's rather long. So let's just say p. Now if we said if p, so we say, actually we'll say variable distance equals, now how to calculate the distance from the player to the asteroid is transform dot position minus p, so that gives us the vector between the two, and then we can just take that, actually let's call that v, so that gives us the vector between the two, and then we say variable d, so I'm using really short names, which is probably not the best thing, but we'll do, right, so that gives us, we're familiar code for calculating the distance from the point that we just chosen to the player. And that, so now we can say if d is less than minimum distance. Now what do we do? Okay, well we need to pick a different point, right? So we can just pick another point. Sure. So does that do what we want? Does anyone spot any problems with that code? What happens, so we pick a random point in the world, we don't know that that point is far enough away from the player, so we check that the point is, if the point is too close, we pick another random point in the world, right? We don't know that this, we've got to check this one as well, right? We can't just rely on the second one we chose being far enough away. We might have chosen 2 in a row which are too close. So what we need to do is keep doing this over and over until we're sure that we've got one that's far enough away. So we need a loop. So an if statement isn't going to cut it here. But what we have is a loop. So what we can do is a for loop won't do it, because the for loop is for doing it a fixed number of times, which again isn't what we want to do. We actually want to do it, keep doing it until we get the answer we want. So what we can say is while, if I can spell, while that distance is too close, pick another point, right? So now this loop will keep running until d is bigger than maximum distance. Now at the moment that won't do anything, d doesn't change from loop to loop, so that would actually be a really bad idea. What we need to do is recalculate d on every loop. So let's do this again, take that code, paste it into there. There. Right. So now we pick a random point. We find how far it is from the player. If it's too close, we pick another random point. We compute how far it is from the player, and we go round and round and round and round until we've picked a point that's far enough away from the player. When finally d is greater than or equal to minimum distance, so this condition isn't true, then we drop out and we set that as the position of the asteroid. Now, because we're picking random numbers, we've got a reasonably good, I mean, we've got to hope that this will eventually finish, because eventually we'll pick a random number which is far enough away. It could be a problem there if we set our threshold too big we might not ever find an answer, and we might go round and round and round in here forever, picking random points, which are always too close. So we've got to make sure that our threshold is small enough that we will eventually find an answer, and we'll get on to the next bit of code. So this works just like an if statement. Come back. Works just like an if statement, only it repeats itself. So as long as the condition is true, it does the code again and again and again. Now, you probably won't actually see. Actually, if we set the threshold large enough, we should see what's going on here. So if we run that, okay, let's set this minimum distance to something fairly big. So about 5. That's still, that doesn't look, okay, let's set it to something bigger than 5. Oops. What did I just do? What did I just do? I think I just removed, oh, there we go, okay. Let's set it to 20. Yep, so you can see now all the asteroids are being generated a long way away. It's actually also taking a little bit longer to initialize, because rather than just compute the asteroids' positions once, it's got to run around and around and around and around until it can find a value that's far enough away. If we set that value too big, like 100, it'll just be stuck now. And it's stuck going round and round in that loop, picking random numbers. Every random number we choose is too close, and so it goes around and does it again and again. Now, you'll notice a problem here in Unity is that when you get into a loop like that, Unity hangs, at least in the editor, and you can't actually stop the code, which is a real nuisance. So, in fact, I don't think I can do anything in Unity because my code is sitting there going round and round and round and round the loop, and nothing else is happening. So now I've got to get out of this. The easiest way I found on the Mac to get out of it is if you come over here to force quit, and you actually have to say Unity, it comes up as Unity's not responding, and you have to force quit Unity in order to get out of that. And there we go. You have forced Unity to quit. Yes, I know. Go away. And now we have to go back and run your own Unity again. Not that one. Not that one, that one. So that's called an infinite loop. It's a loop that will go around and around forever. And this is a typical problem in computer science. When you make a loop and you don't think about, you don't guarantee that it's ever going to actually finish. It'll go around forever, and then your computer will just hang because it's just sitting in that loop going round and round and round and round and round and round and round. So just the summary was, I said, we talked about for loops before, which we said were definite loops. They're definite because they execute a fixed number of times. A while loop is what we call an indefinite loop. It's just, we don't know how many times it's going to run. It'll just keep running until the condition is no longer true. It looks an awful lot like an if statement. We have while, then a condition, and then in braces we have a block of code. And the block of code is executed repeatedly as long as the condition remains true. Now, the condition is checked at the top of the loop. So here's a simple example. We can set the while, so we have a variable d, we set initially to 0. As long as it's less than 10, we pick another random point, we calculate the magnitude of that random point, and then we'll go around again. So executing this, we'd initially set the vector to 0. We'd initially set d to 0. Now 0 is less than 10 is true, and so the code is executed. We pick a new point, say 1, 2, 3. We calculate the distance, which is about 3.74. We go back to the top again. 3.74 is less than 10, that's true, and so the loop will execute again. We pick a new point, in this case 548. We calculate the magnitude of that point, that's 10.2. 10.2 is not less than 10, so that's false, and so we drop down to the end of the loop, and we'll print out the value in this case. So the idea here is that we execute around and around. Now note, we only check this at the top of the loop. So if we look at a piece of code like that, the first time we try to check this, 10 isn't less than 2, and so the code isn't executed at all. So if the condition is false at the beginning, the code will never be executed. So it's like an if statement there. If the condition is already false, just skip to the end. If the condition is that's interesting. That's not an infinite loop. I don't know why I put that there. Anyway, okay. What I meant here was greater than or equal to. I'll fix that. The loop. So here, if d is equal to 10, let's say that's greater than rather than less than. So d is less than 10. So we run the loop once. If we set d to 1 and then set d to 10, we come back again. We only do the test at the end of each loop. So even though d was less than 2 for a little while in the body of the loop, that doesn't matter as long as at the end of the loop we come around and the condition is true again. So yeah, if the condition is just checked at the end or the beginning of each loop, so it's checked the first time and then it's checked every time we go around again. An infinite loop is usually a bug in your code. Sometimes you'll deliberately design an infinite loop in your code, but almost never in Unity will you want to do that. So a for loop that we looked at previously can be implemented using a while loop. And so here's sort of how they're the same. The for loop has the initializer, the test, and the incrementer and a block of code. If we wanted to do the same in a while loop, we'd set the initializer before we entered the loop. We'd put the test in the condition of the while loop. We'd put the block of code there, and then at the end of the block we'd put the incrementer and we come around again. So usually a for loop is a much more sort of concise way of writing that same code. If you write it in a while loop, one of the big mistakes is you often forget to do the incrementing, and so you leave that out. I is always 0, and so the loop goes on around forever. So usually that's why there's a special syntax for doing it in a for loop, is because it's easier to read what that for loop is doing, and it's easier to remember to put all the 3 important parts of the for loop together. But you can implement them using either kind of loop if you want. A while loop is generally more flexible than a for loop. So not every while loop could be implemented with a for loop, but every for loop could be implemented with a while loop. All right, so yes, as I said, they both have an initializer, they both have a condition, they both have an incrementer there, and they both have a block. So, what time is it? Okay, let's do that. We should, let's destroy things. How much time we got left? Oh, okay, we've got a little bit of time left. Let's talk about destroying things. Unity has built-in collision checking to tell if 2 objects have hit one another. There are 2 important things we need to know about to do collision checking. We need to know every object has a collider and every object has a rigid body. We're not going to talk about the rigid body today, but I'm going to talk briefly about the collider because you're going to be using it in today's lab. If you go to this link, you'll see a whole bunch of stuff about how this happens. Now, a collider is like representing the physical volume of an object. It's the way that Unity works out whether a point in space is inside the object or outside the object. Unity provides lots of different kinds of colliders. There's the box collider, the sphere collider, the capsule collider, the mesh collider, and a whole bunch of other ones. A mesh collider will check collisions exactly on an object's mesh. So if you have a complicated shaped object and want to check exactly whether a point is inside or outside that shape, you can use a mesh collider. But the problem is that's very time consuming. So if you have a physical body of your player and you want to check whether a certain point is inside or outside that body, if I have to check every single point inside my volume, it's quite complicated. What I end up doing is using an approximation. So rather than checking whether a point is exactly inside or outside me, I'll wrap a box around me and say any point that's within this box is close enough to be called a collision. Or if I don't like a box, I might use a sphere or I might use a capsule, depending on the shape of your object. If your object is, I'm running out of power, that's because I always forget to turn, no, it's plugged in. I forgot to plug the other end in this time. Sheesh. Blimey. One of these days I will learn how to plug my computer in. So depending on the shape of your object, you might choose different colliders. So, in fact, I'll turn the one of these. There we go. That didn't really work. Oh, it did work. Good. So if you have a person, it would be very time consuming to work out whether or not a point there is inside or outside of that person. And it probably won't matter to you, if you're running a game and you want to work out whether that person was hit by a bullet, probably it doesn't really matter whether or not it's that point or that point. If it was close enough, it's good enough. So what you do is, rather than use a mesh collider, which would do that exactly based on the model of that player, you do a box collider, which might look like that. In fact, you might even make it look sort of like that, which is a box that you wrap around your player. Any point within that box, you would say, is close enough. And so a point here, yes, it's in the box. A point out there, no, it's not in the box. A point that was there, even though it was really on the arm, we're saying it's outside the box, so we don't care about it. And usually that's good enough. Checking for Unity to write the code inside Unity for checking whether a point inside a box is a lot faster than checking whether the point is inside the mesh. So especially for games that have to do this on every single frame, it's a lot cheaper for us to use a box collider than to use a mesh collider. Now, if we've got something that doesn't fit nicely into a box, we might want to wrap a sphere around it. So if we have a short, fat person, we might actually want to do a sphere and say that sphere is the size of that person. Or if we have an asteroid in our asteroids game, we might call each asteroid a sphere rather than calling it a box. The other one you get used a lot is a capsule, it's like a cylinder, but then has a rounded ends on either end, and that's a capsule collider. And all of these kind of colliders are much easier to use than using a mesh collider. So we won't go into any more details of doing collisions. Not that switch. That switch. I think, what did I have on the next? Yeah, okay. So I'll just show you how to put a collider on something, and then we'll leave it at that. So if we look at our asteroid prefab, we'll see our asteroid already has a sphere collider attached to it. The reason why that is because we used the built-in sphere to represent our asteroid. So the built-in box, sphere, capsule, etc., already come with a collider attached to them. Now, if we don't have one of those, so we just remove that for the time being, then we can add a collider to our object by saying component physics, and there's a bunch of different colliders there that we can choose from. And in this case, we'll add a sphere collider, and there it is. It adds it onto our object. So depending on what kind of shape our object is, we can choose a different collider, whatever collider we like for it. And this gives us a way of computing whether or not, a point will be inside it. What we'll be using it for in today's tute is allowing you to click on objects. Because when you click the mouse, the Unity needs some way of knowing whether or not the point you've clicked is inside an object or outside the object. And so what you're going to do is put a collider on that object, and when you click on that object, the Unity will see whether the point you clicked is within that collider. One of the things you can see, if we go looking at let's pick the player, focus down on the player, you can see a couple of things here. So the player has a capsule collider attached to it here. Now we can actually adjust the size of the capsule collider independently of the size of the object. So if we make the capsule collider bigger, so there's the collider. We can, let's scroll out. Which button is it? One of these, that one. So that's a huge collider. We can make that collider a little bit smaller. So there's a small collider. So now, it's a bit hard to see, but so the mesh is the little thing in the middle. The green lines around it show the collider, So now if I was using this as my collider, if I clicked anywhere within that larger space, it would count as a collision. So the collider and the mesh can be completely independent if you want. You can make the collider as big or as small as you want. One of the interesting tricks in real gaming is you do use a mesh collider, but you use two separate meshes. One really complicated mesh to be your player, which has all the facial features and everything on it, and one much simplified mesh which removes all the details and but just has sort of a head and a body and various components. And then it's a lot cheaper the simpler your mesh, the cheaper it is to do collision computations on it. But for what you'll be doing, it'll generally be good enough to just wrap a capsule or a box or a sphere around your object and use that as your collider. All right, in the next lecture we'll show how to check when objects actually collide with one another. But in today's tute, you're going to be working with prefabs and making lots of objects and then clicking on them to kill them. So have fun. Thanks for coming.